Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review everything you need to know for the upcoming test on geometry. So we're going to start with congruence. So two shapes are congruence if one is a translation, reflection, or rotation of the other. Basically, two shapes are congruent if they're the same shape. Same size, same sides, same angles, same area, same everything. It means that you could take one of the shapes like this and you could rotate, translate, or reflect it and it would lie perfectly on top of this. So these two shapes here are congruent. So that means that I must have translated, rotated, or reflected this shape to get this one. Now, it's not always clear which transformation occurred, so sometimes you need to look at the vertices. So to get from here to here, I definitely didn't translate because the orientation has changed. This triangle is facing a different way. But I could have rotated or reflected this shape. To know that, I need to know the vertices. So if I performed a reflection, A would go down here, so I call that A dash, B would go here, and C would stay here. If I rotated this original shape to get this one, it would go around like that, and I would have B dash down here, A dash over here, and C dash would be in the same spot. So the green vertices show a reflection of this shape. The blue vertices are what I would get if I rotated this shape. If you rotate, reflect, or translate a shape, you get an identical figure. You get a congruent shape. All right, let's now look more at congruent triangles. So I said that two shapes are congruent if they have the exact same sides and angles. But fortunately, when we're looking at triangles, in order to determine that they are congruent, we don't need to check every pair of sides and every pair of angles. Instead, we see if one of these four tests hold. So in all of these, S means a pair of corresponding sides that are equal, A means a pair of corresponding angles that are equal, R means right angle, H means hypotenuse, which you remember from Pythagoras is the longest side in a right angled triangle. So just be aware here that when I talk about corresponding sides and angles, I mean matching. I'm not talking about those corresponding angles in parallel lines, I mean matching up. So the first test here is SSS. So here we have 1, 2, 3 pairs of equal corresponding sides. The SSS test says that means these two triangles must be congruent. I don't need to check their angles. I know these two angles must be equal, these two will be equal, and these two must be equal. So if you have two triangles with 3 pairs of equal corresponding sides, they are congruent. So I'm just going to show you how to write a congruent statement. So I want to write that this triangle is congruent to that one. So I write triangle. The first one I can call whatever I want, ABC, CBA, BAC, whatever. And then I use this symbol for congruence. Now, when I'm writing the vertices, so ED and F are the vertices, of the second triangle, I need to get them in order. A corresponds to E because these two angles will be equal. So because I put A first in the first triangle, I need to put E first in the second triangle. Similarly, B corresponds to D, so I need to put D second and then F third. And if you know the test, you can just write it in brackets. This is a congruent statement. All right, the second test is SAS. That's when you have 2 pairs of equal corresponding sides and the angle between them is equal. It must be the angle between to use the SAS test. So these triangles will definitely be congruent. The third test is AAS. So that's where you have 2 pairs of equal corresponding angles and a pair of corresponding sides is equal. The sides must be corresponding, matching up. So they have to be like, in this case, the longest side in each triangle, or they have to be the shortest side in each triangle, but the sides that you use for AAS must be corresponding. And the last test is RHS. So that means you have 2 right-angled triangles, their hypotenuses are equal, and another pair of sides is equal. So I did these diagrams deliberately because a lot of people think if you have right-angled triangles, it must be RHS. No, that's not necessarily the case. If you have right angled triangles, you could be SSS, SAS, or AAS. Don't assume just because you have two right angled triangles, it must be RHS. To use RHS, you do need a right angle in each triangle, but you also have to have the hypotenuses equal as well as another pair of sides. All right, let's now look a little bit more at the SAS and AAS tests. So as I said before, SAS, it must be two pairs of sides and the angle between that are equal in order to use that test and determine congruence. So for these two triangles here, I have two pairs of equal corresponding sides, but it's not the angle between that's equal. So I actually can't use SAS test here. So I can't be sure that they are congruent. I can't use any of the other tests. But if you can't use any of the four tests, it doesn't necessarily mean they're not congruent. If these are not congruent, then I must have a pair of unequal sides or unequal angles. Well, I don't know that. I don't know. These two sides could be equal. I don't know. So for this one here, we say that there is insufficient information to determine congruence. So I can't tell that these are congruent. I can't tell that they're not congruent. So just remember, SAS, it must be two pairs of sides and the angle between. As for AAS, as I said, it must be two pairs of equal angles and the corresponding sides. So if I look at these two, they have two pairs of equal angles, and they do have a pair of equal sides. But I cannot use the AAS test. Reason is these two sides are not corresponding. See, in triangles, the longer side is always opposite the largest angle. So in this triangle, the 8 centimeter side must be the longest side. Whereas in this triangle, 8 centimeters is opposite one of the smaller angles. 8 centimeters is not the longest side in this triangle. It's not opposite the largest angle. So that means that this triangle, its longest side is 8 centimeters, whereas this triangle must have a side that's longer than 8 centimeters. So I can't use the AAS test, but in this case, I can be sure that they are definitely not congruent. They have different side lengths, because this one, the longest side's 8, this one must have a side longer than 8. So these two triangles are definitely not congruent. Just make sure you understand that if you can't use any of the four tests, it doesn't necessarily mean they're not congruent. In order to conclude they're not congruent, you have to be sure that there is a pair of unequal sides or unequal angles. All right, let's now look at using congruent triangles in quadrilaterals. So we're going to attempt this question here. Prove that if a parallelogram has equal diagonals, then the shape is a rectangle. So we would be absolutely mad if we didn't draw a diagram. So here what I'm going to do is draw this shape, and it is a parallelogram. That means it has two pairs of parallel sides. So the diagonals of a quadrilateral are lines joining non-adjacent vertices. So that's these two lines here. What I'm being asked to show is that if these two red lines are equal, then this shape must be a rectangle. So I can do that using congruent triangles. So that I can keep track of what I'm talking about, I'm going to label each of the vertices here. So what I am essentially going to do is show that this triangle here and this triangle here must be congruent. So how do I do that? Well, let's just go looking for equal sides and equal angles. We'll note that AD and BC must be equal. This was part of the question, that the two diagonals are equal. So that was basically given to us. Now also note that this triangle here and this triangle here, they share a common side, CD. So CD is in both triangles, so it must be equal in both triangles. So also note that this side and this side must be equal. AC equals BD. What is the reason for that? We know that opposite sides in a parallelogram must be equal. So we now know that this triangle and this triangle have 3 pairs of equal and corresponding sides. So we can write ourselves a congruent statement. So the first triangle is triangle ADC, which is this one here. I want to say that it's congruent to this one here. And the test I use is SSS. So these two triangles are congruent. Now what that means is this angle here and this angle here must be equal because they are corresponding angles of congruent triangles. We know that if two triangles are congruent, then pairs of corresponding angles are equal. And these are the two largest angles in each triangle. Okay, so that's all well and good that these two angles are equal, but how does that show that this is a rectangle? Well, note that because we have parallel lines, these two angles here are co-interior. Co-interior angles add to 180, so if they're equal, then both of them must be 90 degrees. But because of co-interior angles, if this one's 90, this one must be 90. So these angles are 90, 90, 90. This fourth one, therefore, is also 90 because angles of a quadrilateral add to 360. So this shape here must have 4 right angles. So if a quadrilateral has 4 right angles, it must be a rectangle. That's the definition of a rectangle. 4-sided shape, all angles equal. So that is enough for us to conclude that this shape is a rectangle. Now note, going through this whole process where I wrote out everything, I wrote which things are equal, why they're equal, that constitutes a formal proof. You only need to do that if it says prove. So here I've shown that if I have a parallelogram and its diagonals are equal, all 4 angles must be 90 degrees, so the shape must be a rectangle. All right, let's now take a quick look at unique triangles. So a triangle is said to be unique if it is congruent to any triangle drawn with the same information. We use the same test for uniqueness as for congruence. What does this all mean? Well, let's look at some examples. Are these triangles unique? Is a triangle with side lengths 6, 8, and 10 centimeters unique? What are we really talking about here? Well, let's go ahead and draw one. So if I draw a triangle with side lengths 6 centimeters, 8 centimeters, 10 centimeters, it turns out it's right angled because of Pythagoras' theorem. So it'll look like that. This triangle is unique. Why is this triangle unique? Well, that's because if I were to draw any other triangle with side length 6, 8, and 10 centimeters, it would be congruent to that one. So if I try to draw another one like this, and then this is 10, 8, and 6, these two must be congruent by the SSS test. That's what I mean by using the same test for congruence as for uniqueness. So it turns out if you were to try and draw a triangle with side length 6, 8, and 10 centimeters, your triangle would be congruent to this one. It's impossible to draw another triangle with these side lengths that is not congruent to that one. So that's why we say it's unique. It's like one of a kind. There's only one triangle you can draw with side length 6, 8, and 10 centimeters. Okay, what about a right-angled triangle with side length 6 centimeters and 8 centimeters? So let's go ahead and draw one. So I'm drawing a right-angled triangle, and I could have, like the last one, 8 centimeters and 6 centimeters being the shorter sides. So, is it possible to draw another triangle with a right angle and these two side lengths that is not congruent to that one? So it turns out it is, because I didn't say that the angle had to be in between the two sides. I could also draw a triangle like this, where 8 centimeters was the longest side. These two triangles are not congruent. We can't use SAS because this is not the angle in between the two sides. We can't use RHS because we don't have the hypotenuse here. So these two triangles both are right angled, both have sides 6 and 8 centimeters, but they are not congruent. I can't use any of the congruence tests. They are definitely not congruent because the longest side here is 8 centimeters, whereas here the longest side is more than 8 centimeters. So we conclude that these two triangles are not unique. It is possible to draw more than one non-congruent triangle with side length 6 and 8 centimeters and a right angle. All right, let's now go on to similarity, which is a leap-only topic. So two shapes are said to be similar if both of the following are true. Corresponding angles are equal and corresponding sides are in the same proportion. So I'm going to draw a picture to show you that it's possible to have one of these without the other. So the first shape is a non-square rectangle and the second shape is a square. So let's say this rectangle, for example, is 4 centimeters wide, 7 centimeters is the width. So we know that all rectangles and all squares have all four angles equal to 90 degrees. So clearly, these two shapes satisfy the first condition. They have corresponding angles equal, but their sides are not in the same proportion. When we say same proportion, we're talking about a consistent scale factor. So if we look at these two pairs of sides, the scale factor is 4/4, which is 1. I times this side length by 1 to get this side length. But the scale factor for these two sides is 7/4. I need to times this by 7/4 to get this side length. The scale factor is not the same, so the sides are not in proportion. In other words, for these two shapes, I don't multiply the shorter side of the square by the same number that I multiply the longest side of the square to get the corresponding side in the rectangle. So these two satisfy the first condition, but not the second, so they are not similar. Now, it's also possible that two non-triangle shapes satisfy the second, but not the first. On the other hand, these two shapes are similar. So firstly, we have that pairs of corresponding angles are equal. Those two are equal, those two are equal. Similarly, these two and these two are equal. And we also have that sides are in the same proportion. That's because the ratio of the longest side of the two shapes is 14/7, which is 2. The ratio of the shorter sides of each shape is equal. 10/5 is 2. So this number 2 is called the scale factor. So basically, sides in this larger shape are double the corresponding side length in the smaller shape. So these two shapes are similar. The idea behind similarity is they're the same shape but not necessarily the same size. The idea behind similarity is that one shape is just a larger version of the other shape. All right, let's now look at similar triangles. So only for triangles are those two conditions on the previous slide equivalent. So in any triangles, if sides are in proportion, then angles are equal. And conversely, if angles are equal, sides are in proportion. You can't have one without the other. So when looking to determine whether or not two triangles are similar, again, we don't need to check every pair of sides and every pair of angles. We use tests. Now, the tests for similarity are very similar to those used for congruence. The only difference is AAS is replaced by AAA. And now, S doesn't mean a pair of equal sides, it means a pair of sides in proportion. Similarly for H, it means the hypotenuses are in proportion, not necessarily equal. So are these two triangles here similar? Well, it turns out that they are by the SAS test. So the A part of that's really simple. We have a pair of corresponding angles. Now also note that 10/4 is the same as 7.5. Each of these is equal to 2.5. There's a consistent scale factor. I times this longer side by 2.5 to get this. I times the shorter side by 2.5 to get its corresponding side in the larger triangle. So two pairs of sides are in proportion and the angle between them are equal. So just like for congruence, SAS, it has to be the angle between them. So if we know that two shapes are similar, we can use that to find side lengths. So I already know here that the scale factor is 2.5. That means that sides in the larger shape are 2.5 times the corresponding sides in the smaller shape. So I can use that to find what x is. X corresponds to this side here. So x is in the larger shape, we times by the scale factor. So x will just be 2.5 times 3.2, which equals 8. All right, let's look at this pair of triangles down here. We have the smaller triangle and the larger triangle. Now, it turns out we don't have enough side lengths to use any of these first three tests. To use any of these first three, we would need to have at least two pairs of side lengths. We've only got one pair of side lengths here because we don't know what x is, we don't know what this side is. So it turns out the only option we have is AAA. This triangle here and this triangle here are similar by the AAS test. So why is that? Well, they both share a common angle, so this angle must be equal in both triangles. They also have two pairs of equal corresponding angles. Now, I'm sorry for the ambiguity. Here, when I say corresponding, I'm talking about corresponding angles over parallel lines. These two must be equal, these two must be equal. So, these two triangles are similar by the AAS test. That means that their sides must be in proportion. So, for this triangle, the scale factor is 12 over 8, it's 1.5. Sides in the larger triangle are 1.5 times their corresponding sides in the smaller triangle. So we're going to use that to find x. So this side here in the longer triangle is x plus 5. So x plus 5 must be equal to 1.5 times x. Side in larger shape is 1.5 times side in smaller shape. So we can easily figure out x. We subtract x from both sides. 1.5x minus x is 0.5x. Now we divide each side by 0.5. 10 equals x. Alright, let's now take a quick look at area and volume scale factor. So we actually looked at this when we did measurements. So it turns out if two shapes are similar and their scale factor is k, then the area scale factor is k squared, the volume scale factor is k cubed. So what that means is if you have two shapes and let's say the sides in the larger shape are double the sides in the smaller shape, the area will be 2 squared, 4 times as much. The volume will be 2 cubed, 8 times as much. So let's use that to find x and the surface area here in these two shapes. So we are given the two volumes of similar shapes. I'm telling you that these shapes are similar, so you don't need to prove it. So the volume scale factor is just the volume of the larger shape divided by the volume of the smaller shape. But the volume scale factor is equal to k cubed. So to find k, the scale factor, I cube root this number on my calculator. And what I should get is k equals 5 over 4 or 1.25. The scale factor for sides is 1.25. That means sides in this shape are 1.25 times the size of the sides in this shape. So because x is in the smaller shape, instead of timesing, I divide by the scale factor. So I take its corresponding side of 10 and I divide by the scale factor. Turns out I get 8. So x is 8. So if the total surface area of this shape is 800, what would be the total surface area of this shape? Well, I know that k is equal to 1.25 or 5 over 4. So the area scale factor is k squared. So it'll just be 1.25 squared, which is 1.5625. So What will be the total surface area of this shape? Well, this is the larger shape, so I times by the area scale factor. The total surface area here will just be area of the smaller shape multiplied by the area scale factor. And that just gives 1250. It'll be in the same unit, centimeters squared. Alright, sorry for the long video, but thank you so much for tuning in. Best of luck studying for your test, but you're a star, you'll ace it. This has been the luckiest maths teacher in the world. Have a great day.